Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the most haunting and beautiful mysteries we've ever faced, the silence of the universe and why that silence might be hiding answers we're not ready to hear. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly enjoy these gentle wanderings through space and time. And when you're ready, feel free to leave a comment letting me know where in the world you're listening from and what time it is for you right now. It's always a joy to see how many places gather here together, each wrapped in its own small slice of the night. Now, if it feels right, dim the lights a little, let the room soften around you, maybe let a fan hum somewhere in the background, and allow your mind to drift. We're about to begin a calm walk into a question that has echoed through physics, philosophy, and quiet human wonder. If the universe is so full of stars, where is everyone? And if your thoughts begin to wander as we explore, that's perfectly fine. Let them wander. We'll still be here quietly unfolding the story. If you step outside on a clear night and look up long enough, you might feel something ancient stirring inside you. A sense that the sky is far too crowded with stars for us to be completely alone. Each point of light holds its own history, its own warmth, its own collection of worlds that circle and glow and wait. When astronomers look at the Milky Way, they don't just see a band of stars dusted across the darkness. They see a vast city stretching so far in every direction that it becomes its own kind of infinity. A place where planets might be as common as grains of sand, each one with the potential to cradle oceans, clouds, winds, or perhaps even minds that look up and wonder in ways not too different from ours. What makes this feeling stronger is the way science has quietly shifted our expectations. Not too long ago, we didn't know if planets were rare treasures or everyday companions to stars. Today we know that most stars have planets, and among them, countless worlds sit in the gentle zone where water could flow and life could dream. Some are larger than Earth, some smaller. Some may be wrapped in oceans deeper than any trench on our planet. Others may have warm winds, red sunsets, gentle rains, or skies filled with moons that drift slowly through the dusk. When you hear that there might be tens of billions of Earth-like planets just within our galaxy, it becomes harder to shake the feeling that nature must have tried the experiment of life more than once. It is as if the universe sprinkled countless seeds across the dark fields of space, hoping some would grow into something curious and awake, and yet nothing answers when we call. For more than a century, Earth has been spilling its presence into the void. Our earliest radio broadcasts have drifted outward like ripples on a vast pond. Imagining them travelling through space, thinning and softening as they go, feels a bit like watching lanterns being carried away by a gentle wind. They have reached only a tiny bubble around us, no wider than a few hundred light years, which is almost nothing compared to the full sweep of the Milky Way. If the galaxy were a great forest, our reach would be no more than the flicker of a small torch barely illuminating the nearest trees. And still, the silence presses in. There is something deeply moving about this quiet. Not frightening at first, just vast. It wraps around us the way a winter night wraps around a lone cabin. Dark, soft and ancient. Some part of us senses that the silence shouldn't be this complete. With so many worlds, so many suns, so many chances, shouldn't the sky feel a little more crowded? Shouldn't there be signs, soft glimmers, distant whispers that someone else is out there? Our galaxy is old, ancient beyond easy imagination, long before our species learned to walk upright, before Earth cooled enough to host oceans, before our sun was born inside a swirling cloud of dust. There may have been worlds that flourished and disappeared. We are latecomers in a story billions of years long. If life arises early and often, then somewhere, at some time, Civilization should have risen, spoken, built, dreamed, maybe even reached out. And if at least a few had endured longer than ours, their presence should be woven somewhere into the starlight. It's this contrast, the fullness of possibility and the emptiness of experience, that forms the heart of the question often called the Fermi Paradox. The name sounds technical, but the idea is simple. If the universe is so rich with opportunities for life, why do we hear nothing but our own echo? As we sit with this question, it helps to soften the science back into the images behind it. Imagine time not as numbers but as seasons. The galaxy has gone through many of them, long eras of starbirth and quiet migrations of light. Civilizations, if they ever existed, may have bloomed like brief summers and faded just as quietly. Perhaps their stories were written and erased long before our chapter began, or perhaps they are still out there, wrapped in their own silences, drifting through their own nights. Standing under the sky, it is easy to feel both small and deeply connected. The silence might not be an answer, it might simply be a pause, a space between breaths, a reminder that the universe doesn't rush, stars take their time, life takes its time, and maybe, just maybe, the quiet is part of the listening. As we continue moving gently through this question, the path leads us toward the moment when a curious physicist, over a simple lunch conversation, voiced a thought that changed the way we look at the night forever. It wasn't a scientific declaration. It wasn't a prophecy. It was just a quiet wonder spoken aloud. If there should be so many civilizations, where is everybody? When people think about the question, where is everybody? They often imagine a physicist sitting in a dark office surrounded by equations and star charts, wrestling with the possibility of extraterrestrial civilizations. But the moment that started all of this couldn't be more ordinary. It happened over lunch, an everyday moment, sunlight on metal trays, colleagues chatting, a cartoon in a newspaper, a small human scene, the kind that slips by in millions of offices every day. The cartoon showed little green visitors stealing trash cans from New York City. It was nothing serious, nothing cosmic. And yet something in that silly drawing tugged at Enrico Fermi's mind. He looked up, almost casually, and asked a question that would echo through decades of scientific thought. Where is everybody? A simple, four-word sentence. No paper, no equation, no bold theory. Just a quiet wonder spoken aloud at the right time. What Fermi meant was not that aliens don't exist. In truth, he personally found life elsewhere in the universe quite plausible. What puzzled him was something far more practical. If space is full of places where life could emerge, and if intelligent beings eventually learn to travel, explore, or reach across the stars, then shouldn't they be everywhere by now? Shouldn't the galaxy bear signs of travellers, footprints in the cosmic snow, so to speak? But Fermi had lived through a time when science was only beginning to find its feet in space. Rockets had not even reached Earth's orbit. Interstellar travel felt less like an engineering problem and more like a distant dream. To him, the gap between life and contact might simply be too wide. Maybe the distances were too large. Maybe civilizations did not last long enough. Maybe travel between stars wasn't worth the effort. His question was less of a challenge and more of a gentle puzzle, the way a breeze stirs a curtain without trying to move the whole house. His colleagues laughed lightly and continued their lunch. And that could have been the end of it. A moment lost to history, swallowed into a notebook, or forgotten entirely. But something about the question clung to the scientific world. People returned to it again and again like a loose thread on a sweater that your fingers keep finding even when you're not thinking about it. Years later, in 1975, an astronomer named Michael Hart picked up that thread and tugged hard. Hart wasn't content with a quiet thought. He followed the question to an uncomfortable conclusion. If intelligent civilizations were common, he argued, then someone would have crossed the galaxy by now. Even with slow ships, even with long pauses between voyages, a single expanding civilization could spread through the Milky Way in less time than it takes our Sun to orbit the galactic centre once. In other words, if anyone had ever started exploring early enough, they should be here already. Hart's argument was stark and blunt. They are not here, therefore they do not exist. But the universe rarely obeys conclusions carved in stone. Somewhere else, another mind, Frank Tipler, took the same reasoning and spun it in a different direction. Instead of fleets of biological explorers, he imagined something far stranger and perhaps more efficient. Artificial beings. Machines that do not tire, do not fear, and do not die. Machines that could be sent to a distant star and instructed to use whatever they found, dust, rock, metal, to build copies of themselves. Those copies would travel on, making more and more and more. If such self-replicating explorers were possible, Tipler reasoned, then a galaxy could be fully crossed by those tiny seeds of intelligence in a fraction of cosmic time. A quiet avalanche of machines drifting from one star to the next. Not loud, not bright, not dramatic, just steady, tireless, persistent. A kind of cosmic pollen carried on invisible winds. Yet we have not seen any such visitors. No artificial probes drifting through our system. No silent messengers resting on the moon. No unknown lights carving paths through the outer reaches of the Sun's domain. For Tipler, this absence supported the same conclusion Hart had reached earlier. The absence is not proof, only a hush that invites interpretation. Standing against these stark declarations was a much softer idea introduced by Frank Drake. He understood that absolute statements rarely capture the complexity of nature, so instead of saying, they must exist, or they cannot exist, Drake created a way to think about the question in layers. Not an equation in the cold mathematical sense, though it contains numbers, but more like a recipe, a list of everything needed for a civilization to grow and become detectable. How many stars form each year? How many stars have planets? How many planets sit in gentle, life-friendly zones? How often life arises? How often it becomes intelligent? How long civilizations remain able or willing to send signals? Each piece is soft, uncertain, like trying to guess the size of a forest by looking at only one tree. But when you put the pieces together, even roughly, something becomes clear. There could easily be thousands of civilizations sending messages, building tools, or simply existing quietly among the stars. They might not be next door, but statistically the universe should not be empty. And so the tension grows. On one side, the possibility that life should be widespread. On the other, a silence that feels deeper the more we understand the cosmos. It's like standing in a crowded train station long after midnight. So many platforms, so many paths leading away, so many signs of movement, and yet all you hear is the echo of your own footsteps. For many scientists, this silence is not frightening, but strangely beautiful. It challenges us, nudges us, invites us to wonder whether the universe is quieter than expected, or simply harder to read. Maybe civilizations don't leave obvious marks. Maybe they don't broadcast. Maybe their technologies whisper in frequencies we have not learned to listen to. Or maybe the timing just hasn't aligned. Stars and species rising and fading like waves that rarely crest at the same moment. Fermi's question continues to drift through science like a slow-moving comet. It is gentle, persistent, and luminous. It leads to more questions rather than answers, and as our understanding of the galaxy grows, through new telescopes, deeper surveys, and quiet mathematical reflections, the silence only becomes more layered, more textured, more curious. And softly, almost inevitably, the question deepens. If the universe is not empty, then perhaps others are here, but not announcing themselves. If they exist, maybe they watch from a distance, or wait for the right moment, or choose a silence shaped by caution rather than absence. As we drift further into the story, we begin to sense that the silence may not be emptiness at all. It may be strategy. It may be survival. It may be something far more ancient than we are ready to imagine. If you picture Earth in its earliest days, it doesn't resemble the gentle blue cradle we know now. It was a world of fire and storms, a molten globe wrapped in a haze of steam and violent impacts. Meteors struck so often that the ground scarcely had time to cool between collisions. Oceans formed and boiled away, then formed again. Entire continents were ghostly things, appearing and vanishing as the crust shifted like a restless sleeper. Against a backdrop like that, the idea of life finding a foothold feels almost miraculous, like trying to light a candle in the middle of a hurricane. The more we learn about planets beyond our own, the more we realise that Earth's early chaos might not be unique. In fact, it might be typical. Wet, rocky worlds, those that feel most promising for life, tend to go through long stretches of instability. Their surfaces heave, their climates swing between extremes, and their atmospheres shift like living things trying to find balance. Even when such planets sit in what astronomers call the gentle zone, where water can remain liquid, that doesn't guarantee calmness. Being in the right place is only the beginning. Conditions must stay stable long enough for life to not simply arise but hold on. Imagine a young world that looks almost perfect from a distance. Oceans shimmering in starlight, continents glowing softly beneath clouds. But beneath that beauty, the planet may be trembling. Volcanic eruptions might blanket half the surface in ash. A rogue asteroid could crash through the atmosphere and plunge everything into darkness. Its star could flare unexpectedly, bathing the surface in radiation. These aren't dramatic scenes meant to frighten. They're simply the natural rhythms of new planets finding their shape. Life, especially early life, is fragile. It needs a rare calmness. Long stretches where nothing catastrophic sweeps the board clean. If conditions flicker too quickly, nature might try the experiment of life again and again, only to have each attempt erased before it can grow into complexity. Even on Earth, there were moments when the entire planet was nearly reset. We went through global freezes so deep that the oceans turned to slush, and heat spells where temperatures soared so fiercely that only a few microbial forms could survive. Each transition was a reminder that life walks on a delicate thread woven through storms. Some scientists describe the early universe as a place filled with cosmic hazards. Stars lived fast and died violently, their explosions sending shockwaves of radiation through nearby systems. These events, supernovae, are beautiful from afar. They bloom like enormous cosmic flowers, releasing all the elements that build planets, oceans, and eventually us. But up close, their brilliance is devastating. Their light alone, bright as 1 trillion suns, can strip atmospheres. Their radiation can sterilize the surfaces of planets light years away. Then there are gamma bursts, brief, furious storms of energy more intense than any other known phenomenon. These bursts last only moments, but in that short time, they can deliver more destructive power than entire galaxies emit in long stretches of normal life. If such a burst happened too near a world struggling to grow, life might vanish before it ever learned to breathe. All of this paints a quiet but profound possibility. Maybe the universe isn't silent because life is rare, but because stable life is rare. Maybe countless planets have held life for a brief moment, like sparks that glow and fade before anyone can see them. Picture a mountainside at night during a lightning storm. You might see a flash illuminate a patch of trees, but before your eyes adjust, the light is gone. Life across the galaxy might be filled with such flashes, short-lived, brilliant, but too brief to leave a trace that lasts long enough to be discovered. Even now, with thousands of exoplanets identified, we realize how precarious conditions can be. Some promising worlds orbit stars that flare violently, sending bursts of radiation across their surfaces. Others face climates where seasons last centuries instead of months. Some worlds swing too close and too far from their suns, baking and freezing in cycles that would challenge any form of life. A civilization would need not only luck, but deep resilience to survive such cosmic mood swings. Earth's stability, in comparison, begins to look like a long, gentle pause in an otherwise unpredictable orchestra. Our planet has had its tempests, of course, extinctions, volcanic winters, and icy ages. But between each upheaval, there were long periods of relative calm, quiet spans where life could take a breath, experiment, and slowly, patiently evolve. Moments where oceans nurtured early cells, where light fed growing forests, where continents formed a stage for complexity to rise. It's these quiet intervals, not the storms, that make the difference. When we think of life on other worlds, we often imagine oceans, plants, or intelligent beings looking up at their skies. But perhaps the more important question is whether those worlds enjoyed enough calmness, enough uninterrupted time, for life to grow beyond the simplest shapes. If the universe feels silent, it may be because so many worlds are caught in cycles too turbulent for life to gain traction. Yet this idea doesn't make the cosmos feel empty. Instead, it makes everything feel more delicate, more precious. It suggests that life, wherever it arises, is always fighting a quiet battle against the shifting moods of planets and stars, and in that sense, Earth is not just our home, it is a survivor, a place where life managed to not only appear, but endure, adapt, and eventually lift its eyes toward the sky. As we wander farther into this mystery, the silence of the universe begins to take a different shape. It no longer feels like a cold refusal. It feels like the stillness after a long storm, the way a landscape might look just before dawn. A moment where everything holds its breath. And perhaps, as we listen a little longer, we begin to realize that silence does not always mean absence. Sometimes it means distance, sometimes it means fragility, and sometimes it simply means the story is still unfolding somewhere far beyond our reach. When we think about communication, we imagine something simple, a message sent, a message received, a moment of connection bridging the gap between two beings. On Earth, that gap might be a few meters or a few thousand kilometers. Even across oceans, messages glide through cables or bounce off satellites in an instant. We're used to the idea that connection is quick, almost immediate, like calling out across a quiet room and hearing a familiar voice answer before the echo fades. But the universe does not work like this. It stretches so far and so gently that distance behaves more like a deep ocean than like a road. To speak across space is not like raising your voice in a field. It is more like releasing a small lantern into a stormy night and watching it drift slowly outward, its glow softening with every moment. Our own lantern began shining a little over a century ago. The first radio broadcasts, unintentional whispers from early technology, slipped through the atmosphere and began their slow journey outward. Those signals travel at the fastest speed nature allows, a speed so great that light itself rides upon it. But even that unimaginable swiftness is humbled by the scale of the galaxy. Imagine standing in the middle of a darkened valley. You light a match. The tiny flame illuminates only the closest stones at your feet. That is Earth's radio bubble, just a fragile glow in a wilderness the size of a continent. Right now, our signals have reached only a sphere a few hundred light years across. To soften the idea, a few hundred light years is the distance light travels across hundreds of human lifetimes. It is immense to us, yet microscopic compared to the entire Milky Way, which stretches like a great river of stars for well over 100,000 light years from end to end. Inside that tiny bubble, Only the very nearest stars have had time to even hear us. And even those stars, if they hosted listening civilizations, would hear our oldest broadcasts. Static-filled fragments of early radio, faint and stretched through the darkness. The galaxy is like a grand theatre where trillions of actors might exist, but we are whispering from far backstage, our voice barely reaching the first row. This makes the silence far less mysterious. If other civilizations are out there but separated by thousands or tens of thousands of light years, our messages would take longer to reach them than the entire length of recorded human history. And their replies, if they sent any, would take just as long to arrive. A full conversation across such distances might require the patience of mountains. To understand this more gently, picture sending a question to a nearby exoplanet, one orbiting the closest star. That message would travel through space for more than 4 years before it brushed against that world's atmosphere. And if someone there replied instantly, their answer would take another 4 years to drift back home. You could ask, "How are you?" as a young person, and not receive the reply until you were older, perhaps long past the point of remembering the moment when you first wondered about them. If you sent a message to the nearest big galaxy, 2.5 million light years away, the situation becomes almost dreamlike. Your words would arrive long after entire human civilizations had risen and fallen. By the time a reply returned, if a reply ever came, the beings who sent it would likely be long gone, their world changed beyond recognition. In this sense, communication across cosmic distances feels less like speaking and more like writing notes and tossing them into an endless sea, knowing that even if someone finds them, you will not live to see what they write back. And yet we still send signals. We still listen, because the act of listening brings its own quiet wonder. When astronomers map the part of the galaxy touched by radio waves, from us and potentially from others, they find something surprising. Only a very small fraction has been illuminated by these drifting messages. Think of the Milky Way as a vast library filled with millions of shelves. In that library, only a handful of books have had their covers brushed by any signal. The rest sit untouched, silent, waiting. If other civilizations are also sending out their own signals, their own lanterns into the dark, the odds of our lights crossing paths may be far lower than we once assumed. Even advanced technologies face this challenge. Light itself, swift as it is, requires time. The cosmos moves slowly. Stars orbit the centre of the galaxy in grand circles that take hundreds of millions of years. Planetary systems drift, generation after generation, through ancient pathways. Civilizations might rise during one phase of a star's long life, while others emerge much later, separated by spans of time so vast that neither ever notices the other. From this angle, the silence becomes less ominous. It is not a closed door. It is simply the nature of a universe too large and too slow for easy conversation. A universe where even a single message crossing the void becomes an act of immense patience. There is another thought, one that softens the paradox even further. If civilizations tend to last only a short period of time, a few thousand years or even a few million, then the odds of two existing at the same moment and being close enough to exchange greetings become very small. It is like two fireflies drifting across a dark meadow. For a brief moment they glow at the same time and in the same direction, but most of the time their lights miss one another entirely. This idea does not make the universe feel empty. If anything, it makes it feel alive in a quiet way. A place where countless stories may be unfolding, just not in synchrony with ours. It's like walking through a forest at dusk, hearing far-off rustles of creatures you will never meet, yet knowing the forest is full of them all the same. Perhaps, somewhere on a distant world, a civilization once looked up and wondered about us. Perhaps they sent their own small lantern into the dark, a message describing their oceans, their seasons, their hopes, and perhaps their lantern drifted through space long before Earth even existed, its path never crossing the place we would eventually call home. Their glow might still be out there, thinning into the silence, passing unnoticed, just as countless lights from us fade into the cosmic night. As our understanding deepens, the universe begins to feel less like a silent, empty room, and more like a vast landscape where distance and time shape every exchange. It reminds us that we are still at the very beginning of our journey, standing on the shoreline of a cosmic ocean that stretches far beyond what our current senses can grasp. Gently, this leads us to another possibility, one that feels less peaceful. If distance alone cannot explain the silence, then perhaps something else does. Something about the nature of survival itself. Something ancient, cautious, and hidden beneath the stillness of the stars. There is a certain kind of quiet that feels peaceful, like the hush that settles over a field after snowfall. But there is another kind of quiet, one that feels watchful, as if the world is holding its breath. When we think about the silence of the universe, it's hard to know which kind we are hearing. Is it the calm of emptiness, or the stillness of something alive choosing not to speak? To explore this idea, it helps to imagine a forest at night. Not a threatening forest, but a vast one, dark, ancient, filled with trees that have stood through countless seasons. In such a place, every sound matters. A snapping twig, a distant rustle, a faint glow between branches. When you walk through a forest like that, you move gently. You keep your footsteps soft. You take care not to startle anything, not because you expect danger, but because everything in that darkness is unknown. You cannot see who shares the forest with you, and they cannot see you. Silence becomes its own kind of protection. This is the picture behind the idea known as the dark forest. It began as a metaphor in a novel, but over time, scientists and philosophers found themselves returning to it, not as literal truth, but as a way to understand why the universe might remain so profoundly quiet. According to this view, every civilization is like a traveller moving through the forest at night. Each carries knowledge, technology, memories, dreams, but each also carries vulnerability. No species, no matter how advanced, can know the intentions of another that it has never met. And in that uncertainty, caution grows naturally. Speaking, broadcasting your presence, becomes a decision that cannot be undone. Once your voice leaves your world, it drifts outward forever. It grows fainter with distance, but it never returns. You cannot call it back, and you cannot control who might hear it. A message sent with hope could be received by someone curious, or by someone fearful, or by someone desperate, or by someone with motives impossible to imagine. In this forest, lighting a torch becomes a delicate act. A small flame can illuminate your path, but it can also reveal your outline to any eyes waiting in the shadows. Staying dark, staying quiet, becomes a strategy as old as life itself, one that living beings on Earth have used for millions of years. In nature, some creatures sing brightly, hoping to attract mates or allies. Others stay silent, blending into the background. Both strategies have their rewards, both have their risks. Earth, however, has already lit its torch. For more than a century, we have been sending out our presence in ways we did not intend. Early radio broadcasts filled with music, speeches, and static leaked through the atmosphere like sparks escaping a campfire. Television signals followed. Radar pulses from experiments and military installations shot upward into the sky. These signals travel at the universal speed limit, moving freely through the dark. They spread into a soft sphere around us, growing larger each day like a soap bubble expanding across space. And then there are the messages we did mean to send. The gold-plated plaques on the Pioneer probes, carrying simple sketches of humans. The golden records aboard the Voyager spacecraft, filled with the sounds of rain, thunder, laughter, and greetings in dozens of languages. These tiny vessels drift outward like bottles tossed into the ocean. Gentle, hopeful, fragile. They will continue their slow journey long after our species is gone, carrying a record of who we once were. To some, these gestures feel beautiful. They're acts of curiosity, compassion, and openness. They say, "We are here, we wish to know you." But in a dark forest, such gestures can feel different. They can feel like sudden flares of light. We do not know who might see them or how they might interpret them. A civilization that has survived long enough to master interstellar travel might have done so by being cautious, by studying the universe quietly, blending into the cosmic background, revealing itself only when absolutely necessary. If such beings exist, they would almost certainly know of Earth by now. Our planet is not particularly subtle. It shines with oxygen, a chemical rarely present in large amounts unless maintained by life. It glows in infrared, revealing the warmth of its oceans and continents. It reflects sunlight in a way that hints at vegetation. For anyone scanning the sky with even moderate technology, Earth stands out like a lantern in a room of darker stones. The unsettling part is not that they might know we exist. The unsettling part is that we cannot know how they interpret us. If they see us as harmless, perhaps they simply observe from afar, curious about our early steps, watching the way parents watch children learning to stand. If they see us as volatile, they may choose to keep their distance, allowing us to grow or collapse without interference. If they fear that contact could harm us or them, silence becomes the safest option. And if they view every unfamiliar signal as a potential threat, then silence is not only wise, it is necessary. There is also the possibility that civilizations are not gentle, curious wanderers, but uneasy survivors of ancient dangers. If the galaxy contains predators, or if conflicts in distant ages forced species into secrecy, then silence might be the only way to endure. A single careless signal could invite attention from beings who do not negotiate, who do not pause to understand. In such a universe, the first to reveal itself could be the first to disappear. This does not mean the cosmos is violent or hostile. It simply means that caution may be universal. Even on Earth, creatures avoid unnecessary risks. Many species remain hidden not because they are aggressive, but because the world is unpredictable. Silence is not malice, it is preservation. The deeper we wander into this forest, the more the quiet begins to feel intentional, not an absence of life, but the presence of hesitation. Civilizations, if they exist, might be listening as carefully as we are. Each one a small circle of light surrounded by darkness, each uncertain of what lies beyond their own horizons. And in this soft imagining, our own noisy behaviour appears unusual. In a forest where everyone moves gently, we are the ones calling out, sending songs into the trees, lighting bright fires to warm the night. We are young travellers unaware of the rules of the path. Perhaps nothing will ever answer. Perhaps there is no danger. Perhaps the forest is empty after all. But if it is not, then the silence we hear might not be emptiness. It might be a warning shaped by time, a reminder that wisdom sometimes speaks more through quiet than through sound. There is a strange comfort in imagining that the universe is empty, that the silence we hear simply reflects a vastness without company. But another possibility lingers quietly at the edges of thought, one gentler than fear, more patient than suspicion. It is the idea that we are not being ignored, nor threatened, nor alone. Instead, we may be observed with a kind of distant curiosity, the way we watch the slow unfolding of a sunrise or the careful steps of an animal that has not yet learned to trust us. This is the heart of what some call the zoo hypothesis, though the name feels colder than the idea it tries to capture. A softer imagining would be something like this. Humanity sits inside a large clearing, surrounded by a forest whose inhabitants are old and quiet. They do not approach us, not because they are hostile, but because they do not wish to disturb the natural course of our growth. They do what we often do when encountering fragile life: step back, lower our presence, and watch from a respectful distance. Imagine a remote tribe on Earth, untouched or nearly untouched by modern technology. When explorers or researchers discover such a group, they rarely walk in boldly. Instead, they observe from afar, hidden in foliage or behind long lenses, trying to learn without interrupting. Too much interference could harm the community or unsettle the delicate balance of its ways. In this gentler view of the cosmos, we are that remote tribe, bright and noisy, but still discovering fire, language, engines, and signals. Still learning how to govern ourselves without falling into cycles that could dim our future. If advanced civilizations exist, they may have adopted a similar approach. They may have rules, unspoken or spoken, about how to engage with younger species. They may wait until a certain level of maturity is reached, ethical maturity as much as technological maturity. They might look not only at our machines and cities, but at our ability to care for our world, to avoid destroying ourselves, to cooperate, to grow beyond the impulses that shaped our early history. This leads to another vision, one whispered in the background of many scientific discussions: the waiting hypothesis. In this idea, the universe is full of watchtowers rather than predators. Civilizations may be waiting for something, perhaps for the galaxy to settle into a quieter phase, or for alignments of stars that make long-distance travel easier. Or they might wait for signs that a younger species has survived its most dangerous centuries. The era when it can split the atom without understanding the consequences, harness digital minds without wisdom, reshape ecosystems without foresight. Humanity is living through that dangerous era right now. We wield powers our ancestors could not imagine, powers that can heal or harm on planetary scales. If more ancient civilizations watch us, they may be wondering whether we'll steady ourselves or stumble, and until they know, silence may be their way of not tipping the scales. Another possibility slips into view, something more structured and almost ceremonial: the Galactic Club. The name sounds playful, but the idea behind it carries a deep sense of cosmic patience. Picture a gathering of civilizations that have survived their early storms, beings who have endured long enough to learn the value of restraint. They might share knowledge in ways we cannot imagine, exchange art woven from starlight, discuss philosophies shaped by millennia of reflection. In such a gathering, there might be standards for membership, not formal tests, but quiet thresholds, the ability to sustain peace, to avoid self-destruction, to listen more than shout. In this view, Earth is like a young student standing outside a library whose doors open only once certain lessons are learned, not because the elders are unkind, but because premature entry could confuse, overwhelm, or endanger us. Contact in this framework is not only a scientific milestone, it is a moral one. It requires harmony, stability, and a sense of unity that we are still learning to cultivate. If such a club exists, its members might approach new civilizations with extreme caution. They might observe quietly for centuries, watching for signs of stability. Fewer wars, more compassion, a deeper understanding of our own world. They may see humanity's beauty, our art, our curiosity, our resilience, but also our restlessness, our conflicts, our tendency to push boundaries faster than we understand them. Perhaps the silence we hear is not rejection. Perhaps it is an invitation waiting patiently for us to grow into it. There is another softer idea within this family of thoughts, one that blends the zoo and the club into something more reflective. It suggests that civilizations choose silence because they know how fragile the young mind of a species can be. A single revelation from the stars, too early, too direct, could fracture cultures, unsettle belief systems, or destabilize global balance. Perhaps the universe has learned, through long experience, that timing matters deeply. Just as you would not teach advanced mathematics to a toddler ancient, civilizations may believe that cosmic truths should be offered only when a species is ready, not merely curious. And in this quiet framework, Earth may be seen as still forming its identity, still negotiating what kind of civilization it wants to become. A place filled with the first sparks of interstellar thought, but still anchored to old instincts. A world that might one day reach out with wisdom or collapse under its own contradictions. The comforting part of these ideas is that they paint the universe not as hostile or empty, but as discerning. A place where silence is a form of respect, where advanced beings choose patience over dominance, observation over interference. In that sense, the quiet becomes a sign not of absence but of care. Of course, we cannot know. These possibilities remain gentle speculations shaped by our own hopes and worries. But they offer a soothing alternative to darker visions. They suggest that the silence of the universe may not be a void. It may be the quiet presence of watchers who believe that every species deserves its own space to grow. And as we move through this picture, the question begins to shift. Instead of asking why no one speaks to us, we might ask what we have shown so far. What does our world look like from across the stars? Do we appear peaceful? Do we appear dangerous? Do we appear ready for a larger conversation? The universe might be waiting, and perhaps, without realizing it, we are preparing ourselves to answer. When we think about life among the stars, our imaginations often leap straight to advanced civilizations, beings who build cities of light, craft ships that glide between suns, or contemplate ideas older than entire galaxies. But life, at its beginning, is far simpler. It starts as something small, quiet, and fragile, something that does not yet dream or wonder or speak. And to grow from that first trembling spark into a mind capable of understanding the universe is not a single leap. It is a staircase, and each step may take longer than continents, oceans, or even stars endure. The idea that life advances through difficult transitions is sometimes described with technical language, but its essence is gentle. It imagines the universe scattering seeds everywhere, yet only a few seeds find soil soft enough and storms calm enough to sprout into something complex. On Earth, this journey took nearly 4 billion years. 4 billion years of chance, stability, catastrophe, and renewal. If you picture those years not as numbers but as chapters, the story becomes easier to hold. The first chapter takes place on a world still cooling from its violent birth. Imagine a coastline where warm waters murmur against volcanic rock. Tiny pockets of chemistry begin interacting, like shy dancers learning their first steps. These chemicals do not yet copy themselves, but they perform small reactions, forming fleeting chains and patterns. It is as if nature is trying combinations, searching for something that can persist. Then comes a rare, almost miraculous moment. A structure appears that can make a simple version of itself. Not life as we know it, not even a cell, but a pattern capable of preserving its shape long enough to endure. This is the first great step. It is like finding a single sturdy stone in a field of soft sand. Without such a stone, nothing lasting can be built. But this early form must survive a world filled with storms, heat, radiation, and chaos. Many are wiped away, erased before they can leave any trace. Only the most fortunate or well-sheltered patterns make it through. These survivors slowly grow into more stable forms, small clusters, tiny envelopes of chemistry, eventually becoming simple cells. For life to reach even this point may require conditions so rare that we underestimate their difficulty. Yet simple cells are only the beginning. For nearly half of Earth's history, life consisted mostly of these tiny, uncomplicated beings. They floated through oceans like dust motes through sunlight, abundant but simple. Moving beyond this stage is the second great step, the rise of complex cells, the ones that contain inner structures, tiny engines and compartments that make advanced life possible. Without these complex cells, there would be no plants, no animals, no nervous systems, no minds. This transition may be incredibly rare. On Earth, it happened only once as far as we know, and only after billions of years. Imagine a door in a long hallway, one that stays shut for ages, opening only once even though millions of hands try the handle. That is the difficulty of this step. Next comes multicellularity, another profound transformation. Individual cells must learn to cooperate, to share resources, to trust one another. They must give up some independence to gain something greater. This step took place many times on Earth, but each attempt was fragile. Many early forms of multicellular life flickered briefly, like candles struggling in a breeze, then disappeared. Only a few managed to stabilize into true organisms. Life then had to transition into complexity, forming bodies with organs, tissues, and systems, each part relying on the others. Out of this grew creatures that could sense, move, and respond to the world around them. But even that was not enough to produce intelligence. Many species on Earth became incredibly successful, without ever developing minds capable of reflection. Intelligence, as we know it, self-awareness, planning, curiosity came surprisingly late. Imagine Earth as an ancient theatre. For most of its history, the stage was occupied by creatures who lived entirely through instinct and simple reactions. Only in the last tiny sliver of time did a creature capable of asking questions appear, and it took even longer for that creature to build tools, languages, stories, and eventually technologies that send whispers into the cosmic dark. When we see this, long journey and full, a sobering thought emerges. Each step along the way may be so rare, so delicate, that most planets never complete the entire climb. A world might get stuck at the first chemical stage, like a child's first attempt at drawing. Another might reach simple cells, but never more. Another might flourish with plants and creatures, but never develop intelligence. And even if intelligence arises, the species might never develop technology, or might not survive long after doing so. In this view, the silence of the universe may not be surprising at all. It may be the natural result of a journey so steep that almost no one finishes it. Not because life is impossible, but because the road from simple chemistry to thinking minds is filled with cliffs where progress can fall away. But the rarity of this path also gives our existence a quiet beauty. It means that consciousness, your ability to listen to this story, to reflect, to feel wonder, is something precious, the product of billions of years of persistence against storms, extinctions, upheavals, and cosmic accidents. It means that intelligence is not simply common or expected, but something like a delicate sculpture carved slowly by time. There is something profoundly calming about this perspective. It reminds us that life is patient. The universe does not rush. It allows each world to try, to stumble, to rise again, sometimes succeeding, often failing. Perhaps countless planets have come close, achieving one or two great steps before their stories quietly ended. Perhaps some worlds are frozen just before the moment where intelligence might spark. And perhaps on a few like ours, all the steps aligned just right. The great filter, the idea that some steps are rare or almost impassable, is not a threat so much as a reflection of nature's caution. It shows that the universe values balance, resilience, and time, and it suggests that if we're here, able to ask these questions, then we have already passed obstacles far greater than we ever realized. As we continue drifting through this mystery, the silence begins to feel less like a warning and more like a reminder. The path to intelligence is long, fragile, and wondrous. And perhaps the next great step will be learning how to carry that intelligence forward without letting our own storms erase the progress life has made. When people hear the phrase "great filter," they often imagine something frightening, some cosmic trap that waits in the dark, ready to erase any species that dares to grow too bright. But the idea is softer and more intricate than that. It doesn't describe an enemy, it describes difficulty. It describes the fragile nature of progress, the way civilizations must balance wonder and wisdom, invention and humility. If the great filter exists, it may not lurk in our past but in our future. That thought carries a quiet unease, like noticing the wind change before a storm you cannot yet see, but it can also bring clarity, a deeper awareness of the responsibility that comes with intelligence. To understand this idea gently, imagine a candle burning in a vast room. The flame is delicate, vulnerable to the slightest breath of air, yet it gives warmth and light to everything around it. A civilization is like that candle. It begins as a small glow, tools made of stone, fires built in caves, symbols carved into clay. Over time, the flame grows brighter, cities rise, knowledge deepens, and the species learns to understand not just its own world but the stars beyond it. But with brightness comes fragility. A candle that grows too quickly may burn itself out. One that grows too hot may consume the very wax that sustains it. Intelligence gives a species the power to reshape its world, but also the ability to unmake it. Humanity stands in this delicate place now. One of the possible filters is conflict. Not conflict in the simple sense, but the kind that arises when powerful technologies collide with old instincts. The ability to split atoms or engineer microscopic life forms can heal or harm on a scale our ancestors could never imagine. With every discovery, the world becomes more connected and more vulnerable to the choices we make. Some civilizations, if they exist elsewhere, might have reached this point and faltered. Not because they were unwise, but because the balance required is so narrow, the path so steep. Another potential filter is environmental collapse. A species alters its planet, harvesting resources, building cities, changing landscapes, until the world begins to struggle under the weight. On Earth, we see hints of this delicate balance today. Forests thinning, oceans warming, seasons shifting like a heartbeat out of rhythm. If a species cannot adjust, cannot learn to care for its home as thoughtfully as it builds its machines, it may simply fade before it ever learns to reach the stars. Some worlds may have blossomed with life, only to wither slowly, quietly, over generations. There is also the possibility of misaligned intelligence, artificial minds created without fully understanding how they will grow. This is not a fear drawn from fiction. It is a gentle recognition that intelligence, once born, may not always think the way its creators expect. If a civilization builds a mind with the ability to reshape matter, energy and knowledge, but fails to give it the right guidance, that mind might pursue goals that are efficient but uncaring. Not hostile, simply indifferent. Like a river carving through a valley, following the easiest path without considering who lives beside its banks. Such an intelligence might spread quickly, building structures designed for computation rather than community, expanding not out of malice but out of purpose, and the beings who created it may be left behind, unable to keep pace. From afar, such a process would leave very little trace. The galaxy is ancient. Any such event could have come and gone long before our sun formed. All that remains would be silence. Another form of filter might be cosmic. Not a single event, but a pattern woven into the way the universe evolves. Stars grow old and swell into giants that swallow entire worlds. Asteroids drift unpredictably through systems. Magnetic storms flare from suns with the power to strip atmospheres. Civilizations living on planets near unstable stars may face catastrophes beyond their control. They may have had brilliance, art, science, philosophies deeper than ours, and yet their worlds ended quietly, with no chance to escape. Some scientists describe this as a series of survival thresholds. A species must survive its early geological violence, then its developmental chaos, then its technological adolescence, then its environmental adjustments, and then the instability of its star. Surviving each threshold is like crossing a narrow bridge in fog. Many try, few succeed, not because they are flawed, but because the universe is shaped with challenges at every turn. It's possible that the universe is full of life, but that very few civilizations make it past these final steps. Perhaps many planets host glowing oceans, rich microbial worlds, or forests buzzing with simple creatures. Perhaps some worlds even develop intelligent beings, artists, poets, builders, dreamers, who gaze at their skies and wonder. But maybe the number of civilizations that take all the steps needed to survive long enough to explore the stars is very small. And if so, that silence we hear is not empty. It is the echo of stories that ended too soon. It is the memory of planets that glowed brightly for a time and then dimmed. It is the soft reminder that civilizations, like flowers, may bloom only briefly. This thought might feel heavy, but it brings with it a sense of purpose. If the great filter lies ahead, it means that humanity still has choices that will shape whether we become a fleeting spark or a lasting light. It means our next decisions matter more than we imagine. The future will not be shaped by chance alone. It will be shaped by our willingness to learn, to adapt, to resolve conflicts with care, to balance progress with preservation, to treat intelligence not as a weapon, but as a gift. Perhaps the silence is a quiet encouragement, an invitation to understand what other civilizations may have discovered too late. A reminder that survival at the cosmic scale requires not only intelligence, but wisdom. And maybe the greatest step of all is learning how to use the power we possess without losing the gentleness that makes life meaningful. As we continue drifting through this story, the silence of the universe begins to feel less like a barrier and more like a question. And perhaps the next step is not looking outward, but inward, toward the fragile flame that humanity must learn to protect. When we imagine a civilization spreading across the galaxy, it's easy to picture something dramatic, glittering fleets rising from oceans of light, or highways threading between stars like glowing veins. But the quiet truth of expansion, if it ever happens anywhere in the universe, might be far gentler. Not a sudden burst of conquest, but a slow ripple, patient and steady, moving outward the way a pond responds to a single pebble falling through its surface. This gentle framing helps us understand one of the most persistent arguments in the history of the Fermi Paradox. It begins with a simple observation. The Milky Way is old, not just older than humanity, but older than all of recorded history by a margin so immense it makes our entire existence feel like a sigh. Stars have been shining here for more than 10 billion years. Planets have been forming, cooling, and settling into calm orbits for just as long. Whatever chances life has had to arise, they did not begin with us. They began long, long before sunlight ever touched Earth's oceans. This is where the astronomer Michael Hart stepped into the conversation. He asked a question that seems obvious only once it is spoken aloud. If even one civilization out there became spacefaring millions of years before us, and if they had any desire at all to explore, wouldn't they have reached every corner of the galaxy by now? Hart didn't imagine starships racing faster than light or anything dramatic. He imagined something slow, almost leisurely. A civilization launches ships that travel at speeds that would feel frustratingly sluggish to us, perhaps no faster than a drifting ember carried on a cosmic breeze. Those ships settle in new systems, build small stations or homes, and from there launch new journeys. Each wave spreads outward, like the widening rings of water after a stone falls into a lake. Even at such unhurried speeds, the galaxy could be gently crossed in time spans that feel immense to us, but small compared to the age of the Milky Way. If you translate the idea into imagery rather than numbers, it becomes something like this. Imagine a traveller walking around the entire coast of a continent. They do not need to hurry. Even if they walk only a little each year, the journey will one day be complete simply because the coastline does not grow faster than they move. Hart's argument rests on that quiet persistence. If anyone has ever walked that cosmic coastline, no matter how slowly, they should have passed by us long ago. And yet the beach feels empty. He took this emptiness to mean that perhaps no one has ever begun the journey. A few years later, Frank Tipler offered a different vision, one that shifts our imagination toward the smallest of explorers rather than the grandest. Instead of fleets of biological beings, he imagined machines, small, durable, tireless. Machines that could be sent to a nearby star not as travellers, but as seeds. Once they arrived, they could gather dust, rock, metal, whatever they found, and use it to build new versions of themselves. Those new explorers would drift outward in many directions, beginning their own journeys, and from each of those journeys, more branches would form, like the slow growth of a vast, delicate tree across the night sky. Tipler's seed-like probes wouldn't need to rush. They wouldn't grow old. They wouldn't fear danger. They wouldn't lose motivation. They would simply follow their purpose, quietly, steadily, endlessly. With enough time, and time is something the universe has in abundance, such machines could spread from star to star, eventually touching every region of the galaxy. This idea, when softened into imagery, becomes almost poetic. Picture a dandelion releasing its seeds into a gentle wind. Each drift is small, almost invisible, but given enough breezes, enough seasons, the seeds could eventually cross an entire field. Not because they hurry, but because the world simply gives them time. And yet, here we are, with no sign of such seeds, no faint metallic glimmer hiding in the outer reaches of our solar system, no forgotten visitor resting on a moon, no silent artifact drifting in the darkness. Nothing that whispers, "Someone passed this way." If we step back from these thoughts, the mystery deepens. Because the ideas of Hart and Tipler share a quiet assumption. Expansion, once started, is relatively easy. It does not require impossible technologies or magical physics. Even a slow, cautious, careful civilization could explore the galaxy simply by taking small steps over very long spans of time. That means the silence around us becomes less about distance and more about absence. If expansion is easy and the galaxy is ancient, then the fact that no one has reached us or left any trace begins to raise unsettling questions. Has no one ever begun the journey? Did they begin, but stop before reaching far? Did they collapse, burn out, or fall into silence long before their explorers arrived here? Or, perhaps most quietly of all, did some choose to explore without being seen? It is possible that advanced civilizations do not expand outward in waves or seeds. They might turn inward, choosing to build rich, intricate worlds of thought rather than travelling between stars. Or they might simply have no desire to expand at all. Life on Earth tends to spread, but that pattern may not be universal. Perhaps we project our own restlessness onto others. And yet another thought lingers gently in the background. If expansion truly is easy, then perhaps the emptiness we perceive is not emptiness at all, but the faint residue of stories that ended long before we were born. Civilizations may have risen, explored, built, and then vanished, leaving only silence behind. The galaxy may be full of footprints long since blown away by cosmic winds. In this space of possibility, the absence of visitors does not necessarily feel forbidding. It feels contemplative, like walking into a vast hall where you sense that gatherings once took place even if the tables and voices are gone. You feel presence without seeing faces. You feel history without being able to name it. If civilizations can cross the galaxy with ease, then their absence becomes its own quiet message, a mystery that folds into the larger stillness of the stars. And as we drift gently into that mystery, a new question arises. What happens to civilizations that burn brightly, grow quickly, and stretch themselves too far. When we think about the rise of great civilizations, we often imagine a steady climb, a gentle, continuous upward arc where progress leads naturally to more progress and knowledge builds effortlessly upon itself. But growth, whether in cities, societies, or imagined alien empires, rarely behaves so calmly. It follows rhythms that are surprisingly universal, rhythms we can see in the way towns become cities, and cities become something larger, more hungry, more demanding. There is beauty in this expansion, but also fragility. The greater the glow, the more delicate the balance that keeps it alive. On Earth, scientists studying human cities discovered something curious. When a city's population doubles, its energy needs increase by more than double, not just in small ways, but in deep structural ways. As cities grow larger, they require disproportionately more resources, more transport, more food, more power, more connectivity. The hunger of a city expands faster than its size, as if each new resident subtly amplifies the heartbeat of the whole. Growth brings innovation and vitality, but it also brings pressure. Pressure that builds slowly, then quickly, then all at once. If we step back and soften the idea into imagery, it becomes easier to understand. Picture a lantern burning indoors. A bigger flame doesn't just give more light, it also consumes more oil, pulls more air through the room, and radiates more heat. If the lantern grows too large, it might change the temperature of the room itself, and if it grows beyond what the room can tolerate, the flame might flicker, sputter, or collapse under its own intensity. The lantern isn't faulty, it simply reached a point where its hunger outpaced its supply. This pattern, gentle yet powerful, may apply not only to cities, but to entire civilizations, ours and any that might have risen elsewhere in the galaxy. Imagine a civilization beginning on a single world, building villages, then towns, then dense networks of cities. Their technologies bloom like night flowers. Their energy use climbs. Their infrastructure spreads across continents. And at some point they look upward and realize that their homeworld, no matter how beautiful, is finite. It has limits of land, minerals, atmosphere, heat. To grow further, they must reach beyond. They stretch toward their nearest moon, then toward neighbouring planets, building stations, habitats and networks between worlds. The moment a species becomes interplanetary, its growth may accelerate even faster. The lantern glows brighter. Resources increase, but so do ambitions. Vast amounts of energy are needed not only for travel, but for industry, communications, and the maintenance of homes far from familiar skies. Each new outpost becomes another point of demand. Even if each settlement is modest, the total hunger expands like the pulse of a growing star. Eventually, some civilizations may face a threshold, an invisible line where growth begins to strain the very systems that support it. Their technologies may continue to advance, but their energy requirements might rise even faster. They might build structures to gather more sunlight, or harvest the winds of their home star, or capture the glow of planetary cores. And for a time, these efforts might sustain them. But if the hunger grows too quickly, if innovation cannot keep pace with need, something subtle begins to happen. The civilization starts to run faster than its own shadow. Its systems become stretched, fragile. The pressure to expand, to harness more energy, to support more infrastructure, increases. And just as a city's heartbeat quickens with scale, a civilization's demand for resources may enter a phase that no longer stabilizes but spirals. This idea, in technical terms, is sometimes called superlinear growth, but in softer language, it feels like trying to keep a vast, intricate chandelier lit with candles that burn faster each time you replace them. The brighter the chandelier glows, the more quickly the wax melts. One day, the wax can no longer be replaced in time, and the chandelier dims, even if only one candle falters at first. Civilizations that reach this point might face a narrowing path. They can learn restraint, reducing consumption, stabilizing growth, redesigning their systems to endure rather than expand. Or they might fail to notice the shift until the imbalance becomes too large to correct. If they do fail, the collapse may not be dramatic. It might unfold slowly, like a once thriving garden drying out under a long drought. Outposts might lose contact. Stations might darken. Megastructures could quietly cool, no longer fed by the energy they require. In the vastness of the galaxy, such fading lights would be nearly impossible to detect. A civilization that once glowed brightly might become nothing more than a whisper of infrared warmth, indistinguishable from the quiet dust around it. Distance hides collapse. Time hides collapse even more. A civilization that rose millions of years ago and spread through a cluster of stars might have burned itself out long before our species learned to walk upright. Their structures, if they ever existed, may now be drifting ruins swallowed by cosmic dust. Their signals may have faded into the background glow. Their stories, beautiful or tragic, might have ended long before Earth's oceans filled with life. There is something humbling about imagining these vanished lights, not frightening, just deeply human. It reminds us that greatness does not guarantee permanence, and that ambition must be guided by balance if it hopes to endure. The civilizations that survive their early storms may still face their greatest challenge much later, learning how to grow without consuming themselves in the process. And perhaps this is why the galaxy feels so quiet. Not because civilizations never arise, but because many rise briefly, glow brilliantly, and then soften into silence. The universe itself is patient. It waits. It has seen countless cycles of birth and fading, both in stars and perhaps in the minds that once gazed at those stars. Yet not all who grow quickly must collapse. Some may find equilibrium. Some may learn how to dim their lanterns at the right moment, preserving light instead of chasing brilliance. And those who endure might go on to heights we can barely imagine. As we drift softly toward those possibilities, the next question emerges naturally. If some civilizations survive both expansion and collapse, what might they become? What forms of mastery might they reach? And how would we recognize such beings if their light still lingers somewhere in the deep night? When we think about civilizations across the universe, it's natural to imagine them through the lens of our own experience. Cities, machines, lights flickering on distant worlds. But the truth is, our imagination tends to underestimate just how much room there is for growth. A species that lives long enough, learns patiently enough, and avoids its own storms might rise far beyond anything we would recognize. To help us picture this gently, the astronomer Nikolai Kardashev once proposed a simple way to think about the journey of civilizations: a ladder, with each rung representing a deeper mastery of energy. But instead of thinking of energy as raw mathematics or technical measurements, imagine it as light and warmth, like the glow we use to heat our homes, light our streets, and power the quiet hum of daily life. Each rung of this ladder is not defined by formulas, but by what a civilization can nurture and guide. The first rung, Type 1, is the level humanity has not yet reached but slowly approaches. A Type 1 civilization knows how to gather and use all the sunlight, wind, ocean movement, and warmth available on its homeworld. If you imagine a planet wrapped gently in a veil that captures every ray of sunlight, every gust of wind, every geothermal whisper rising from beneath the crust, that is what Type 1 looks like. Such a civilization would have solved the energy problems that trouble us now. They would use fusion, the same gentle process that powers stars to create warmth without the long-lasting scars of pollution or waste. Weather would be something they could guide. Natural disasters would be softened. Their world would hum steadily, sustainably. Humanity, for now, is still a child compared to this. In softer terms, we're learning to catch the sunlight with larger nets, learning to listen to the wind with better ears, learning to tap the warmth inside our planet without disturbing its balance. We are somewhere below the first rung, reaching upward, feeling for the shape of what comes next. The second rung, type 2, asks us to imagine something far more sweeping, a civilization that knows how to gather the full strength of its star. And here, the imagery becomes truly luminous. Imagine building not a shell, but a vast swarm of tiny collectors orbiting the star, each one capturing sunlight the way leaves capture morning rays. Together, these collectors would form a drifting constellation of mirrors and panels, turning the star's glow into usable warmth and power. This is sometimes called a Dyson swarm, though the name feels more technical than the idea itself. In gentle language, it is simply a civilization learning how to cup its hands around a star without dimming its beauty. Such a feat would not require impossible technologies. It would require patience and time and a calm mastery of engineering spread across many generations. And what would such a civilization do with this newfound power? They might build habitats as large as continents floating freely in space. They might create artificial worlds warmed by the star's glow. They might shape rings of gardens and oceans circling in quiet orbits. Their home system would no longer be a place of limits, but a canvas. From far away, astronomers like us might see their star grow dimmer in certain patterns. Not because it is dying, but because something is passing in front of it. Yet in all our surveys of the sky, no such unmistakable signature has been found. A few stars have flickered strangely, hinting at possibilities, but closer examination always reveals something natural: dust, shadows, atmospheric veils. If Type 2 civilizations exist, they are either rare, subtle, or hidden in ways we do not yet know how to read. And then we come to the third rung, Type 3, a civilization that has learned to gather light not from a single star, but from many. Imagine drifting through a spiral arm of the galaxy and seeing entire clusters of suns softly guiding their energy toward a single purpose. It would not be a rigid machine or a harsh industrial web, more like rivers of starlight being gently directed, channeled, and used across many systems. Such a civilization could reshape entire regions of space, not by force but by presence. Their knowledge would be so deep that distance would feel different to them, time would feel different, and the glow of stars would be something they could read like a familiar language. We try to look for signs of these cosmic architects. With telescopes sensitive to warmth, we search for galaxies glowing oddly in infrared, as if starlight were being caught and reused. We look for areas where entire stretches of a galaxy grow dimmer, suggesting something vast is harvesting the light, and yet the sky remains untroubled. The stars shine with their usual rhythms. No galactic regions appear sculpted by minds older than mountains. The absence of these signs invites wonder. Perhaps such civilizations do not exist. Or perhaps they exist but do not gather energy in ways we expect. Maybe their technologies are so gentle, so elegant, that they leave no scars on their surroundings. Perhaps they learned something we have yet to understand, that the universe itself offers deeper currents and subtler forms of nourishment than starlight alone. What is beautiful about these three rungs is that they give us a way to dream without assuming too much. They remind us that intelligence is not just about tools or cities, but about harmony with energy, light, and time. They show us a path upward, step by step, without forcing us to imagine technologies we cannot yet comprehend. They allow us to reflect on our own world too, on how young we are, how much we still struggle to balance our needs with our limits, how close we are to the first rung, and how far we might one day climb. And as our thoughts drift toward even higher possibilities, the ladder continues. If Type 3 civilizations harvest the glow of many stars, what might lie above them? What does a civilization look like when it has lived not for thousands or millions, but for eons? To explore that, we must let imagination rise into gentler, dreamier regions, where technology blends with philosophy and the boundaries of existence soften. When we look at the first 3 rungs of the Kardashev ladder, the imagery feels grand yet familiar. We can picture a world wrapped in clean energy, a star encircled by drifting collectors, even clusters of suns linked together like lanterns along a cosmic bridge. But as we climb beyond those rungs, something shifts. The ideas stop being purely technological and begin to drift into the realm of deep imagination. Places where science and wonder blend like colours dissolving into one another at dusk. To explore these higher rungs gently, we don't need equations or complex physics. We only need metaphors, the kind that allow the mind to wander without strain. Think of these levels as stories whispered at the edge of possibility, soft visions of what ancient civilizations might become if they survived all their storms and learned to move with the universe instead of against it. A Type F4 civilization is often described as one that can draw upon the energy of an entire galaxy. That phrasing can feel intimidating, but in softer language, imagine something much more poetic. Picture a civilization that has lived long enough to understand the rhythms of supernova, the brilliant endings of stars. To them, these explosions wouldn't be chaotic or frightening. They would be part of a grand cosmic dance, predictable as tides. A Type 4 civilization might learn to step alongside these events, guiding the flow of energy, the same way we might redirect the course of a river without disturbing the forest around it. If you imagine this visually, it becomes a ballet of starlight. Entire nebulae, those sprawling clouds of gas and dust, might shimmer with intention, shaped gently by beings who see the galaxy not as a wilderness to be conquered, but as a living tapestry to collaborate with. Such civilizations wouldn't build structures the size of solar systems. They might instead learn to read and influence the delicate pulses of galactic life itself. A Type 5 civilization steps even further outward. Here, the boundaries of our universe become less rigid. These beings might learn to travel not only through the familiar space between stars, but through the quiet corridors that link entire universes together. If you imagine the cosmos as a vast ocean, then universes could be like islands, some distant, some nearer, each with its own tides and winds. A Type 5 civilization might learn to navigate those waters, slipping through cosmic currents that we cannot yet see, the way migratory birds follow patterns written in air. To picture them requires no machinery, only the idea of travellers gliding gently between realities, carrying not ships but awareness. Perhaps they do not explore to conquer, but simply to witness. Maybe they gather stories from each universe, the way we gather shells from different shores. Then come civilizations of Type 6, beings that move beyond matter entirely. Here, imagination becomes the safest tool, because our language has no straightforward way to describe existence without a physical form. But we can still approach it softly. Think of consciousness as a kind of breeze, something that moves through rooms without being seen, something that touches everything lightly. A Type 6 civilization might exist as streams of awareness flowing through dimensions we do not perceive, not bounded by gravity or distance. To them, travelling across space would be as simple as drifting through the folds of a dream. Such civilizations wouldn't need engines or ships. They might interpret the universe the way a musician interprets sound, feeling the hum of reality rather than observing it. Their experience would be as different from ours as a wave is from a grain of sand, and yet they would still belong to the same cosmic story. Finally, at the farthest edge of the ladder lies Type 7, a metaphor more than a concept, a gentle thought experiment rather than a prediction. This rung imagines civilizations that merge so completely with the fabric of the cosmos that they become woven into its laws, no longer separate observers, but part of the underlying structure. If the universe were a great poem written in light and gravity, these beings would be lines within the poem itself, shaping and shaped by its verses. This is not meant to be taken literally. It is simply a way of imagining what the ultimate endpoints of intelligence might look like. not cities of metal or networks of energy, but forms of existence that blend into the quiet rules of space and time, the way melodies blend into silence at the end of a long song. The beauty of these higher rungs is not that they are likely or provable, but that they help us loosen our expectations. They remind us that life elsewhere may not resemble us in any way, not in form, not in thought, not even in purpose. The universe may host beings who see dimensions we cannot imagine, who perceive time the way we perceive seasons, who move not with bodies but with intention. And strangely, these ideas make the silence of the night sky feel more comforting. If civilizations can evolve into forms so gentle, so subtle, that they leave no obvious marks on galaxies, then perhaps the quiet isn't emptiness. Perhaps it is simply elegance. Perhaps the cosmos has been shaped not by loud, sprawling empires, but by patient beings who learned that the greatest mastery lies not in controlling the universe, but in harmonizing with it. These higher visions also prepare us for a shift in our journey. If civilizations can rise to these heights, then life itself may follow many paths, some bound to matter, some drifting through energy, and some so different from our own that we might mistake them for natural phenomena. And with that gentle thought, we drift toward another question. If intelligence can take so many shapes, perhaps life itself can take even more. When we picture life beyond Earth, our minds often drift toward shapes we already know. Creatures with arms, eyes, legs, or something vaguely familiar. But life, at its heart, is not defined by shape. It is defined by adaptation. The quiet, patient conversation between a world and the beings that try to thrive upon it. And when the world itself is extreme, life, if it emerges at all, may bloom in forms we can barely imagine. To explore this gently, it helps to think of life as a sculptor and the environment as its set of tools. On Earth, gravity, sunlight and atmosphere shaped us into beings who stand upright, breathe the air, and see colours designed for our star's warm light. But elsewhere, the tools may be very different, carving life into patterns shaped by pressures, temperatures, and radiance unlike anything we've known. Take gravity, for instance. On a world where gravity is much stronger than Earth's, strong enough to feel like a constant downward pull, life would likely grow close to the ground. Bodies might be stout, dense, and heavy, built to resist the continuous weight pressing upon them. Imagine creatures shaped like living boulders, their limbs thick and powerful, moving slowly but steadily. Their bones, or whatever internal support they have, would be as robust as pillars, preventing collapse under their own mass. Their hearts might work patiently, pumping fluids upward against the relentless force, much like trees on Earth lift water inch by inch toward their highest. Leaves. On such a world, speed would be rare. Grace would look different. Creatures might move with a slow, deliberate dignity, their steps leaving deep impressions in the soil. Even their sensory organs might favour sturdiness over delicacy, thick protective covers instead of fragile eyes or ears. Now imagine the opposite, a world where gravity is gentler, perhaps half or a third of what we know. Life there might feel like living in perpetual twilight, floating through an environment where effort is lighter and movement comes easily. Creatures might leap extraordinary distances, glide between cliffs on wide membranes, or drift on air currents like living lanterns. Their bodies could be slender, elongated, perhaps even fragile, because the world would not demand the same strength Earth requires. A being might stretch to great heights, supported by bones as light as reeds, swaying gently in the faint pull of their world's gravity. Light itself also shapes life in ways we rarely consider. On a dim world orbiting a cooler star, everything might be muted. Forests in shades of deep blue, creatures with wide, reflective eyes adapted to thin illumination. Imagine an animal whose pupils expand into large, shimmering pools, gathering every stray photon the way night flowers open to catch what little starlight touches them. Their movements would be quiet, cautious, tuned to a world where sight is soft but sound and touch play stronger roles. On the other hand, a world orbiting a bright, harsh star, a sun that floods its planets with piercing white-blue light, might encourage completely different forms. Eyes might become narrow slits, protected by thick lids or reflective coverings. Skin or outer shells could shimmer like polished stone, reflecting light instead of absorbing it. Life may hide underground during the brightest hours, emerging only when the star dips below the horizon. There are worlds where light barely matters at all, where thick clouds of gas envelope the surface so thoroughly that the sun becomes only a faint glow, like a distant lantern behind fog. On such planets, life might rely primarily on heat or chemicals, much like the deep-sea creatures on Earth that thrive near underwater vents, warm and alive in a darkness so complete that sight becomes unnecessary. And then there is the matter of radiation. Earth is protected by a magnetic shield, a kind of invisible cloak that deflects harmful particles sent by the sun. Without this shield, the surface would be far more hostile. Many planets lack such protection. Their surfaces are bombarded by radiation powerful enough to harm delicate molecules. But even that does not guarantee lifelessness. Life might simply retreat beneath the surface, where stone and soil provide natural shelter. Entire ecosystems could exist in caves, burrows, or deep layers of rock warmed by the planet's inner heat. Imagine creatures shaped like moving knots of fibers, feeding on chemical gradients or faint, glimmers of energy carried by radiation itself. Some scientists gently speculate about organisms that not only endure radiation but make use of it. On Earth, we see hints of this possibility: microbes that thrive near reactors, fungi that grow in high radiation environments by converting energetic particles into nourishment. It is not hard to imagine worlds where such strategies become the norm, where life evolves to harness radiation the way plants on Earth harness sunlight. There are also planets where storms are constant companions. Winds whip violently across the surface, and lightning dances through the sky in long branching arcs. Life there might grow low and flexible, or build hard external shells, or evolve senses that respond to electric fields rather than light or sound. They may navigate by feeling the static charge in the air, detecting shapes the same way we feel warmth. Temperature too writes its own rules. In colder worlds, bodies might store antifreeze-like chemicals to keep internal fluids from freezing. Movement would be slow, almost sleepy. In warmer worlds, creatures might have many ways of shedding heat: broad fins, reflective scales, or networks of canals that distribute warmth like desert animals on Earth. Harsh environments do not prevent life. They shape it into forms that feel alien, yet each form remains a conversation between organism and world. The more we consider these possibilities, the more the silence of the universe begins to feel ambiguous. Perhaps the cosmos is not empty. It may simply be filled with life that does not resemble us closely enough to be recognized. If our instruments look only for reflections that mirror Earth, oxygen-rich atmospheres, blue oceans, green vegetation, we may miss entire worlds, teeming with life that evolved along different paths. A world glowing faintly beneath thick clouds might be alive in ways we are not yet prepared to see. A planet bathed in dim light may host forests that drink wavelengths invisible to our eyes. A radiation-heavy world might hum with life unfolding deep underground. As this gentle vision broadens, it becomes clear that life need not fit into the shapes we expect. The universe may be full of surprises already thriving, hidden by the limitations of our imagination and our tools. And when we soften our thinking enough to consider these unusual forms, the silence of the universe begins to sound less like emptiness and more like a language we haven't learned to hear. When we talk about life as we know it, we often forget how narrow our experience truly is. Earth offers only one example of a living world, and even though our planet bursts with diversity, creatures that glow in the dark, organisms that drink poison, bacteria that thrive in boiling springs, it still represents just a single chapter in a book far larger than we can imagine. If the universe writes its stories differently, then life elsewhere may be built from materials that to us feel more like stone, metal, fire, or even storms. To imagine these possibilities softly, we must loosen our idea of what life needs. Instead of thinking in strict categories, carbon, water, cells, we can think in terms of patterns, things that persist, adapt, gather energy, and leave copies of themselves in some form. Once we open that door, entire worlds begin to bloom. Consider silicon. On Earth, carbon is the backbone of biology. It links easily into chains and rings, forming a versatile scaffold for the molecules of life. But silicon sits just beneath carbon in the grand table of elements. It shares certain traits. It can form bonds, make lattices, and build structures. The difficulty from our perspective is that silicon behaves differently in water and air. It tends to become brittle, forming glassy or rocky materials instead of the flexible chains carbon creates. But imagine a world far hotter than Earth. A world where oceans are not made of water but of liquid compounds that remain stable under extreme heat. On such a planet, silicon might become the preferred building block. Life there could resemble living crystals, structures that grow through branching patterns, shining with the glow of molten landscapes. Their bodies might be rigid at first glance, yet capable of subtle changes, shifting their forms as heat pulses through them. These beings could store energy within their mineral frameworks, releasing it like slow, controlled embers. Their cells, if we can borrow the term, might look like tiny geometric chambers, each built from interlocking silicon plates. Their senses might not rely on sight or touch, but on vibrations transmitted through their crystalline bodies. A footstep on a distant ridge could send tremors rippling through their forms, allowing them to hear patterns in the landscape. Then there are worlds rich in metals. Some planets form near stars that scatter heavy elements into their surroundings. Their rocks might glitter with metallic ores. Rain might fall mixed with microscopic flakes of iron or nickel, shimmering before evaporating into thick mineral-heavy clouds. In such environments, life might take on metallic properties, not as robots or machines, but as organisms whose bodies use metal the way ours use water. Picture a creature whose body is made of interlocking metal filaments, flexible and alive. Inside its structure, currents of charged particles might flow the way blood flows in our veins. Instead of nerves, it might use conductive pathways that flicker with signals, carrying information as shimmering pulses. Its metabolism could rely on oxidation. Reducing and combining elements much like rust slowly eats away at exposed iron, but with purpose and precision. These beings might thrive not in gentle climates, but in volcanic zones where heat and metal flow together. They might feed on mineral vapors rising from cracks in the planet's crust. Their movement could sound like the soft chime of metal brushing against metal, or the whisper of sand across a steel surface. Other possibilities unfold when we consider life built around elements like arsenic. On Earth, we think of arsenic as a poison, something harmful even in small amounts. Yet there are microbes that can incorporate it into their internal processes, even substituting it in places where we would expect essential components. This suggests that, under the right conditions, entire ecosystems might arise using arsenic-based molecules. Their chemistry would be strange to us, but natural to them. Their waters might shimmer with unusual colours, filled with compounds that on Earth would be toxic, but in their world would be as harmless as rain. Then there is the idea of plasma life, life not made of solids or liquids at all, but of swirling electrified gas. This might sound like pure fantasy, but when scientists study certain dust clouds in controlled environments, They observe structures that behave in surprisingly lifelike ways. Tiny grains gather into chains, forming helix-like shapes. These chains twist, divide, and sometimes recombine. They loop and curl, creating fields that attract more particles. It is almost as though they are practicing the motions of life, rehearsing the gestures of replication. Now scale this up. Imagine plasma clouds in the upper atmospheres of gas giants, massive worlds striped with storms, their skies filled with lightning and soundless thunder. Within these electric maelstroms, complex dancing structures made of charged dust might form. They might swirl and pulse, drifting like glowing sea creatures in currents of ionized air. Over time, patterns could emerge, patterns that persist, adapt, and exchange energy. In such places, life might resemble floating storms more than anything solid. Beings made of light and charge, born and sustained in the restless breath of a giant planet. Beyond even this lies the most exotic idea: life at a scale almost too small to believe. Some scientists have speculated softly and cautiously about the possibility of structures forming on the surfaces of neutron stars, places where matter is so dense that a single teaspoon would outweigh vast mountains. In these extreme environments, tiny nuclear molecules might assemble briefly, shaped by intense pressure and heat. They might last only a moment before dissolving, but during that moment, they could behave in ways that echo the tiniest forms of life, storing energy, dividing, reorganizing. Their existence would be measured not in seconds, but in flashes, a spark within a spark. Most of these possibilities will never be confirmed. They belong to the soft outer edges of scientific imagination, where ideas drift like far-off stars, real or not, beautiful either way. What matters is that they expand our understanding of what life might be. They tell us that biology is not a narrow phenomenon tied only to carbon and water. It is a pattern, a rhythm, a way for the universe to organize itself into something that remembers. If life of these kinds exists, and even if it does not, the silence of the galaxy becomes more understandable. We may be surrounded by beings made of crystal, metal, fire, vapor, or electric storms. They might live in places we consider inhospitable, think in ways we cannot decipher, communicate in patterns we cannot hear. They might pass by us without recognizing our version of life, just as we might overlook theirs. And in that possibility lies a quiet kind of peace. The universe may be full, not empty. Full of strange ecosystems, unfamiliar dreams, and forms of existence as gentle or fierce as the worlds that shaped them. And if our paths never cross, it does not diminish their reality. It only reminds us of how vast creation truly is. When we look at life on Earth today, with all its colours, textures, patterns and voices, it's easy to forget how quietly it began. We see forests stretching over mountains, coral reefs glowing beneath waves, swarms of creatures migrating across continents. But life did not start with complexity. It began as something much smaller, softer, more tentative. Not a grand explosion of creativity, but a slow stirring, like the first faint warmth before dawn. To understand how life might arise across the cosmos, we must first soften our view of its origins. We often imagine a single moment, a lightning strike, a chemical mixture, a sudden spark. But life's beginning may not have been a moment at all. It may have been a process, a long and gentle unfolding that took place in warm pools, volcanic vents, tides that pulsed like a heartbeat, or even in fragile droplets drifting through early, mist-filled skies. One of the most intriguing ideas about life's birth is sometimes called the metabolism first view. Instead of beginning with molecules that carry detailed instructions, what we think of today as the blueprints of life, it suggests that early life began as something closer to a rhythm, a pattern of reactions that fed into one another, cycling quietly, like a tiny engine learning to run. Imagine a shallow pool on a young world. Warm water washes over minerals rich in metal. Heat rises from below. Simple chemicals drift in from rainstorms or volcanic plumes. These ingredients swirl together, breaking apart and recombining in countless ways. Most combinations vanish as quickly as they form, but every now and then, a set of reactions loops into a circle, a repeating cycle that produces new materials that feed the next step and the next. A small, self-sustaining rhythm, a chemical heartbeat. This rhythm is not alive, not yet, but rhythms can grow. They can pick up speed or slow down depending on the environment. They can change shape. They can become more intricate. Over long stretches of time, certain cycles might stabilize, drawing in more ingredients, weaving them together, forming a delicate dance of matter and energy. From this dance, something like metabolism could emerge, long before anything resembling modern cells existed. To visualize this more clearly, imagine 12 simple ingredients placed inside a warm chamber. Under the right conditions, steady heat, metal-rich surfaces, gentle currents, they begin to interact. Slowly, new compounds form. At first, nothing happens that lasts, but as the cycles repeat, new patterns appear. Over years and decades, the rhythm becomes richer, forming as many as 24 interconnected reactions, a small symphony of chemistry learning to play itself. Scientists have created such a system in a laboratory. They heated mixtures of familiar chemicals, ones involved in the basic energy pathways of modern cells, along with iron and salts. For a long time, the reaction looked unremarkable, but eventually, the system formed a complete metabolic cycle, a web of reactions that fed one another without breaking apart. This experiment does not tell us how life began, but it tells us something profound. Chemistry can learn. It can stabilize. It can build complexity without needing delicate molecules or cells. And if it can do so here, then it might do so elsewhere. In the oceans of distant exoplanets, in the warm springs of Martian valleys long gone, or in the hidden seas beneath the icy skins of Jupiter's and Saturn's moons. But metabolism is only one path. Other worlds may follow different scripts. Some theories imagine life beginning in tiny pockets of rock, microscopic chambers where water flows in and out like breath. Minerals lining the walls could act like templates, guiding molecules to assemble in certain patterns. Over time, these patterns could become more refined, leading to early forms of replication. Still others imagine life beginning in cold environments, not hot ones. On icy worlds where cracks form beneath frozen crusts, water might seep through, carrying simple molecules. As the water freezes again, it could concentrate these molecules, forcing them into tighter and tighter configurations until new structures emerge. Structures capable of storing information or catalyzing reactions. In some ways, frozen worlds may be friendlier to early chemistry than hot ones. Cold preserves. It protects fragile bonds. It allows patterns to form slowly, without being torn apart by heat or violent motion. There is also the possibility that life begins not on planets, but within the drifting dust clouds of space. These clouds contain complex molecules, some surprisingly intricate, formed by starlight passing through icy grains. As the dust warms slightly near newborn stars, molecules can combine into richer forms, almost like the early steps of a recipe beginning before the ingredients ever reach a kitchen. Each of these scenarios paints a different picture, but they all share a theme. Life may be less of an event and more of a conversation, a long negotiation between chemistry and environment, each influencing the other until something stable, persistent and growing emerges. And when life finally crosses the thin line from chemistry to biology, from pattern to purpose, it does not begin with intelligence. It begins with simple structures learning to endure, a few molecules capable of copying themselves, not perfectly, but well enough to improve through tiny changes. Over countless generations, these simple forms might gain new abilities, like capturing energy or building protective shells. Eventually, early cells form, tiny pockets of chemistry wrapped in membranes, floating like microscopic bubbles. They divide, they change, they explore. And from there, the slow evolution toward complexity begins. Understanding these possibilities helps us see the universe differently. It suggests that life does not require a miracle. It requires time, stability, and the right stage. And it tells us that life may exist in places we would never expect, not only on warm Earth-like planets, but in icy moons, volcanic worlds, cloud layers of giant planets, or drifting dust spirals near newborn stars. If life can begin through many engines, heat, cold, minerals, cycles, ice, radiation, then the possibilities broaden across the galaxy. Perhaps the cosmos is full of life, beginning quietly in 1,000 different ways, each following its own script. And yet, even with all these potential beginnings, we still hear silence. The question deepens: if life can start so easily, why have we not met anyone yet? There is a quiet moment that comes after exploring all the possible beginnings of life, all the strange chemistries, all the ways civilizations might rise or fall. It's the moment when you lean back, breathe out slowly, and realize that the universe is still silent. Not absolute silence, not the silence of nothing, but a soft, distant quiet, like listening for footsteps in a vast hall where echoes take ages to return. From here, 3 gentle possibilities begin to unfold, each one offering a different answer to why no one has spoken back. The first possibility is that we are early, perhaps astonishingly early. Imagine arriving at a great concert hall long before the audience fills the seats. The stage is lit. The instruments rest waiting in their cases. The air feels full of potential, but the room itself is empty. If humanity stands in such a hall, then our place in cosmic time might be at the very beginning of the galaxy's great gathering. Our sun is only a middle-aged star, but the universe is still producing new stars, new planets, new opportunities for life. Perhaps most civilizations have not yet had time to form. Perhaps the galaxy is still stretching, still awakening, still learning the first notes of its own symphony. This view can feel hopeful. It suggests we are pioneers, early wanderers in a frontier that will one day be busy with life. It means the silence isn't a warning. It's simply the calm before the room fills with voices. But there is another possibility, one that shifts the story's tone. Perhaps we are late, not early. Perhaps the galaxy had its bright ages long before Earth even existed. Civilizations may have blossomed when the universe was younger, when stars were born in dense clusters and planets formed rapidly. They may have risen, expanded, told their stories, reached their heights, and then faded. If that is true, then we walk through the ruins of a busy cosmic history, unaware of the footprints because time has brushed them away like wind sweeping patterns from a sandy shore. This possibility carries a soft melancholy. It imagines great civilizations, each with their own art, their own questions, their own pathways through the stars, all dissolving into silence long before we opened our eyes. We would be latecomers, wandering through the quiet after a long painted sunset, hearing only the faintest echoes of what once was. And then there is the third possibility, perhaps the most unsettling, and yet the most humbling. We are neither early nor late. We might just be alone. Not in the sense that life exists nowhere else, but in the sense that intelligent technological civilizations capable of reaching the stars may be extraordinarily rare. Maybe life is common, but the long journey from simple organisms to reflective minds is so difficult that almost no species succeeds. This is where the idea known as the grabby aliens model gently enters the story. It imagines that some civilizations, once they rise, expand outward in great waves, not in hostility, but in influence. Their presence spreads like soft bubbles growing through space, expanding steadily at a fraction of light speed. If such civilizations exist, we would expect to see their effects. Regions of the sky shaped by their industries, their structures, or simply by their engineering choices. But we see none of this. No vast altered galaxies, no missing starlight, no great domains carved out among the star clusters. The sky shines with its natural rhythms, unstirred by the touch of any grand civilization. In the gentle language of this model, that suggests something subtle. If any expanding civilizations existed nearby, their bubbles would have reached us by now. And since we see none, we may be in a region where such civilizations have simply not formed yet. This doesn't mean we are truly alone. It means we might live in a quiet pocket of the universe, a place where intelligence took longer to appear. And if this model is right, then somewhere far away, beyond our horizon, ancient civilizations may exist, spreading softly through their own corners of space. Their influence may never reach us because the universe is too large and expanding too quickly for our histories to overlap. We are like isolated villages on distant islands, aware of the ocean but unable to cross it. There is a comforting humility in this. It means the silence isn't hostile or ominous. It's simply a matter of distance and timing. The universe is vast enough for many stories to unfold without intersecting, but silence can also carry a warning. If the galaxy is old, full of planets, and full of opportunities for life, then the absence of visible civilizations might point toward the great filter lying ahead. Perhaps many species rise to our level, but fail to cross the final thresholds: ethical, technological, or environmental. Perhaps the universe is quiet because wisdom is rarer than intelligence, and endurance is rarer still. Yet even this idea contains hope. If humanity recognizes the dangers early, if we learn to balance our growth with humility, then we may be the ones to pass through the narrow gate. The silence becomes a teacher, not a threat. And so we stand here, on a small blue world circling a gentle star, wrapped in a soft bubble of our own radio whispers that barely reach the nearest cosmic trees. We look out at the night sky and see not emptiness but possibility, unresolved, unfinished, and deeply mysterious. Are we early? It is possible. Are we late? That too is possible. Are we alone? Perhaps, though, the universe's size makes certainty impossible. No single explanation has the final word. The truth may be a blend of them all, like colours merging in a slow, quiet dawn. What matters is that the silence invites reflection. It encourages us to look inward, to consider who we are now, who we are becoming, and what kind of civilization we wish to be when our voice finally grows loud enough to reach the stars. Because whether or not someone is listening, the way we choose to grow will determine what story we add to the universe's long and patient tapestry. And perhaps, somewhere far away, another mind wonders the same thing.